Okay, so let's run through some problems in section 4.5. This is rational functions. On the left side here, I have a whole bunch of notes that you're going to want. These are all the notes that you need for finding asymptotes of rational functions. So get a picture of that, take a screenshot, whatever you need to do, copy those down, hit pause on the video if you need to, but those are the notes that you're going to want. I believe starting with maybe problem 3 in this section. But as far as problem 1 goes, we're just finding domains of functions. And generally speaking, there are two main rules for domains at this point in this class. And with rational functions, the main rule that we're going to use is that the denominator cannot be 0. In this example, the denominator is 8 minus x, so we're going to say that cannot equal 0. And then we're going to add x to both sides, which basically just tells us that x cannot equal 8. If you drew this out on a crappy number line, you can notice that this domain is everything, the entire real line, except for that one point x equals 8. So what that does is it splits our interval into two pieces, one from negative infinity to 8, not including 8, and the other from 8 to infinity. So that is the domain for this problem. I'm going to let you guys do problem 2 and move on to problem 3 in this section, which asks us to find the vertical asymptotes of this function. Now, if we look up to our notes up here, if we're looking to find vertical asymptotes, the first thing that we want to do is factor and simplify, and then we want to set our denominator equal to 0. So let's go back down, let's factor this thing. Notice that the denominator is a difference of squares, and a difference of squares in this example factors into x minus 4 and x plus 4. To find those vertical asymptotes, we're going to set denominator equal to 0. Now we have two factors multiplied by one another, set equal to 0, so we're going to split that thing into two pieces. And the first piece is going to give us x equals 4, and the next piece is going to give us x equals negative 4, and those are the vertical asymptotes. X equals 4 and x equals negative 4. You do want the x equals with those asymptotes because vertical asymptotes have to be vertical lines. And the equation of any vertical line is x equals something. Okay, so it's asking us now for an oblique asymptote. And if we look at our rules for oblique asymptotes, you only get them if the degree of the numerator is 1 bigger than the degree of the denominator. So we will not get any oblique asymptotes in this case because the degree of our numerator is actually 0 and the degree of our denominator is 2. So we're going to go with no oblique asymptotes. Good job. As far as horizontal asymptotes go, let's take a look at our rules. We get a horizontal asymptote of y equals 0 if the degree of our denominator is bigger than the degree of our numerator. That is the case for this function. So we do have a horizontal asymptote, and the equation of that horizontal asymptote is y equals 0. As far as graphing these functions, I'm going to let you guys use Desmos or your graphing calculators or something like that. Take a look, see which one of these 4 options it is. I'm going to move on to problem 4. And for this problem, we need to find some asymptotes. The first step when finding asymptotes is to factor and simplify. So again, we have a difference of squares in our denominator. In this case, it factors into x plus 3 and x minus 3. Nothing cancels, so we have factored and simplified now. Now, as far as vertical asymptotes are concerned, we're going to set the denominator equal to 0. That's x plus 3 and x minus 3. And we end up getting one vertical asymptote from each one of these two factors. We have a vertical asymptote at x equals negative 3 and another at x equals positive 3. Now, what other asymptotes might we have here? If we go back up to our rules about asymptotes, and we inspect the degree of the numerator and the degree of the denominator, we'll notice that the degree of the numerator is 1, while the degree of the denominator is 2. That means that the degree of our denominator is bigger than that of the numerator, so we have a horizontal asymptote at y equals 0. Combine the information that we found below with that horizontal asymptote, and it looks like the first option for me is the correct answer. Again, I'm going to let you graph these things on Desmos or using your graphing calculator. So I'm going to move on to the next problem. Okay, let's write this function down. And we're going to find the vertical asymptotes again of this function. Again, the vertical asymptotes can be found by setting the denominator equal to 0. Of course, first we'd have to factor and simplify, but there's nothing to factor and simplify here. So we just have this equation for our vertical asymptote. Adding x to both sides gives us x equals 1 as our vertical asymptote. Okay, next problem. We're going to find the vertical asymptotes. And don't forget that means that we're going to factor and simplify first. So it looks to me like we can actually factor an x out of this denominator. So I'm going to factor that x out of each term. And now we're left with a quadratic in our denominator, and I bet we can factor that as well. Unfortunately, this is one of those situations where we have an a which is not 1 in our denominator. So you can factor the rest of this using guess and check, or you can factor by grouping using that a times c technique. But however you factor, you should end up with that quadratic turning into 9x minus 10 times x plus 1. You'll notice now that one factor of x from the denominator cancels with one factor of x from the numerator. After cancellation, that leaves us with 2 factors in the denominator. So if we want the vertical asymptotes here, we're going to take those 2 factors and we're going to set them equal to 0. And each one of those factors is going to end up giving us a vertical asymptote. If we set our first factor equal to 0, we're going to have to add 10 to both sides. And then we're going to divide both sides by 9. That's one of our vertical asymptotes. This factor here is going to pretty quickly give us a vertical asymptote of x equals -1. So our leftmost vertical asymptote is going to be x equals -1. It's the furthest left on the number line. Our rightmost vertical asymptote is going to be x equals 10/9. And we canceled this x from the denominator here, so it's not going to give us a vertical asymptote. We're going to talk about this at some point, hopefully in this homework. But this cancellation of x in the denominator gives us what we call a removable discontinuity. That basically just leaves a hole in our graph, and that hole happens in this case at x equals 0. Okay, but I think that we answered the question. Good. I think I'm going to stop the video here and split this up into small pieces. So move on to the next video. I'll see you there.